Hello everyone and welcome to another video about set theory. In this video we're going to talk about what happens when we put sets inside sets. Mostly this just gets confusing. We're not going to introduce any really new concepts here, but we're going to talk about some things that can get confusing. So in our first video about sets, we talked about how anything can be a set. You can have a set that has in it blue, one, and servitude could be your set, right? And there doesn't have to be anything connecting them, and there doesn't, they can just be anything you want. Now this also means that a set can be a member of a set. So imagine the case where you have these three sets: the set containing X, Y, Z, the set containing A, B, and C, and the set containing I, J, and K. And we decide that those are all members of some other set, A, right? So we're creating a set of sets of three letters, right? This set would look like this. A contains the set containing X, Y, and Z, the set containing A, B, and C, and the set containing I, J, and K. Those are the members of A. Now this looks really confusing, and you can imagine that if you have a set of sets, you would get even more confusing. Right, but we're going to start with this fairly simple example of a set containing sets. So our first question is, what is the cardinality of our set A? Now remember that we show signal cardinality by taking the name of the set and putting lines on either side, and that's asking how many members does this set have, right? So when we go back to establishing the membership in this set, we see that we have one member, two members, three members. This means that the cardinality of A is 3. Even though we can see all these different letters, there's still only 3 things sitting in that set. This set A, when it's counting its members, doesn't care about how many members the sets that are its members have, right? It can only see these brackets, right? It only sees set, set, and set. It doesn't know what's inside when you're counting its the number of its members. This is a little easier to see if we give each of these member sets, if we give them each a name. So if we call this B, and we call this C, and we call this D, right, we can then rewrite this set A as B, C, and D, and it becomes much clearer that you really only have 3 members to that set. So if you're ever having trouble with one of these kinds of problems, give each of the sets within a set a name, and then rewrite your sets of sets in this way in order to make it clearer, how many members each set has. And, that will help you certainly on these cases where it's just a set of sets. It gets more complicated when you have sets of sets and stuff like that. But be careful to count the brackets. Count the brackets. That's my advice. All right, so there are a couple other things. If you understand this, then you're basically going to understand the rest of this, but the rest should help you with many problems that you'll see in set theory. So our first question is, given the set A up here, is X a member of this set? The answer to that question is no. X is not a member of this set. X is a member of B, right? X is a member of B. You've got X as a member. But the only thing that is a member of A is this set, is the set B is a member of A. So X is not a member of A. What would A have to look like if X were a member of A? We would have to write our set A as the set containing B, C, and D, and then it would also have to contain X, right? And in that circumstance, we have then X is a member of A. But we'd have to rewrite our set A so that X can actually be listed right alongside all those sets, right? in order for it to be a member, right? So we'd have to insert another thing in here that's X, right? Is how we would do this. Now we ask another question. Is B a subset of A? Now this is really tempting to just say, oh yeah, it's a set inside there, so it must be a subset, right? But we have to go back and carefully look at our definition of a subset. So remember that in our definition of a subset, we say for any X that's a member of A, or is a member of B with these letters. For any X that is a member of B, X must also be a member of A. Right? So let's look at what are the members of B. Right? Here's our set B. X, Y, and Z are our members of B. Now let's look at X first. Right? We already asked this question. Is X a member of A? No! So this is false. And we can say that no, B is not a subset of A. What would A have to look like if B was a subset of A? So we have our original set A, which contains B, C, and D. And then we also have to make sure that every member of B is also a member of A. So let's go back and look at our members of B. X, Y, and Z also have to be members of A. So let's look at that and we'll add them. X, Y, and Z. And then we can close out our set. Right? And now when we go back and evaluate this, for any X that's a member of B, X is also a member of A. We have X, Y, and Z are members of A. And so now B is both a member of A and B is a subset of A. So these will be a lot of the sort of how well do you understand sets clarification questions that you will encounter. These are really good ways to make sure that you're understanding all the concepts involved, is to look at these examples with sets within sets. So I hope this little tutorial has helped you deal with sets of sets.